Let's take a look at how to configure a Polaris system. First, open Motion Tools and go to the Configuration tab. Now I'll walk you through the various configuration options. I won't go into detail, they can be found in our documentation. So to begin, at the top you can name the server. So here I've got it named with my desk. And then next we have a path planning section. Here you can configure how the controller generates path commands. The next section is the MCI general parameters. Here is the default motion parameters loaded. So you can change things like speed, acceleration, and jerk. The next section is the machine G-code setup. You can change how the G-code parser works and also some other general G-code things. The next, our first device is the controller. In the controller section you can change the controller name. You can also add some of the behavior of the digital IOs. Next is the first amplifier I've connected. So we have here, it has an access number of 0, and I give it its units in millimeters. When I open up the amplifier section, I can give it a name. So it has a name Axis X for now. The SPU program describes the SPU file to load. That's the control algorithm that's currently loaded for the system, or for this amplifier. The first parameter here that we have that we should change is the encoder gain. We'll come back to this shortly. Because I have a special type of amplifier, it has a secondary encoder gain, so we can just ignore that. The next section here is the Mercury address. This should be unique for every device. Typically it's loaded by default by the Polaris system, so you don't have to worry about it. The next section is rollover. This is useful if you have a rotary device. You can have it roll over at 360 degrees. So right now it's configured to off. Triggering is a feature that is available for a system. You can read more in the documentation. In the amplifier digital I/O section, you can trigger or change the behavior of the amplifier's digital inputs and outputs. The phasing section is important for when you first start. You should change the counts per electrical revolution to match the motor that you're connected to. We'll go over that shortly. Limits is another important section. You should enter your motor limits before you begin using your motor. You want to make sure you change things such as motor voltage, the peak current, the continuous current, and there's a bunch of other parameters you can read about that you may want to change as well, such as the following error, how much position error are you willing to tolerate before you want the amplifier to turn off, that kind of thing. The next section is for motor brake. There you can configure the motor brake if there is one, turn it on or off. There's also a shunt resistor section. If you choose to use a shunt resistor, you should configure it. And next are some configuration things for the encoder. Typically these values don't need to be changed. Finally, for the amplifier, there's an MCI section. This is the amplifier specific motion control section where you can again change the speed, acceleration, and jerk. And the G-code section is amplifier specific. Here you can map this amplifier to a specific G-code axis. Here it's mapped to the x-axis. In the error response section, you can turn on or off and change the behavior of individual errors. You can read more about these individual responses in our documentation. And for each of them, you can configure whether they are turned on or off on startup. And some other behaviors, so hardware and software responses are both available. So now let's go back and look at those important parameters that you should change for every system on startup. So the first one that's most important is the encoder gain. So I've got here some data that I've added for my motor, so these things should be pulled from a motor data sheet. So first of all, you should notice encoder spacing. This is the spacing between encoder pitches, or encoder lines that are used for giving you the feedback position of your motor. So my motor has an encoder spacing of 20 microns, 20.48 microns. Pole pair spacing is the distance between magnetic poles. So typically pole pairs we talk about. And that's useful for phasing. The next thing I pulled from the motor data sheet is the peak and continuous current. And also it's useful to know that for this type of amplifier, which is a sine cos encoder type, it has an interpolation factor of 16,384 counts per encoder pitch. So you need to do some calculations to calculate the encoder gain. We want to know how many counts, or how much distance there is per encoder count. So we know from the datasheet that there's this amount of space between encoder spacings, and we know that there's this amount of counts per spacing. So take one and divide by the other, and you get encoder gain that's given here. So let's enter that in. We go up, encoder gain. Okay, so the next important parameter was in the phasing. We go there. You'll have to enter this parameter in order to control the motor at all. And you have to make sure you have the right value or else it won't work. So the counts per electrical revolution, as the name suggests, it's the number of electrical counts per electrical revolution. So let's see how that's calculated. So we know there's one encoder count per 0.2048 millimeters. That comes straight from the datasheet. And our hardware interpolates 4 electrical counts per encoder count. And we know that there's 30.5 millimeters per electrical revolution. Again, that comes from the datasheet. And that gives us a final answer of 5,957 and 132 of a count. So that fraction is important. You'll notice below the counts per electrical revolution, there's an entry for phase fraction. That fraction should be entered there, and that's to ensure that no decimal points are dropped by our firmware. So let's enter that number there. And don't forget the phase fraction. That's how it's entered. Finally, we should enter the limits. So that comes again from the datasheet. So my motor voltage, I'm using a 24 volt power supply and adding a bit of tolerance for any back EMF. I can use a value of 30 volts. Peak current tells me it is 10.06 amps. Continuous current is 3.18 amps. And that's it. So now we should save these values. I'm happy with the falling error of 1. So to save it, you just go stop Polaris server and then start it, and it will load the previous values. That's all there is to configuring a Polaris system.